What's up everyone? Today I bring you an update for my geometry along a curve tool. This is going to be release 1.0, which includes a streamlined workflow and also implementation inside Unreal Engine. So to showcase it, the 1.0 release, I made this zip file that you will have an access to that you can see the so that you can see the common workflow for the tool and basically how to set up. And also this update also includes the complete integration inside Unreal Engine. So we can basically anything that we create inside Houdini, we can recreate it inside Unreal Engine by copying geometry along a curve. So this is a little bit of a simpler setup, but basically any features that I showcased during the video inside Houdini, you can easily copy the geometry inside Unreal, basically transfer it by instantiating a geometry from the content browser. So yeah, so the previous release, so a little bit of a let's take a look at the history of this tool. So the initial video was about angle-based instancing, and this is still basically supported, but it isn't really the main focus of the tool right now. Basically, remember when I made this video about the pipes, maybe you saw them, and then the geometry release 0.9, which is basically there was a bunch of different ways of generating geometry along the curve, but the tool wasn't really basically wasn't really focused on anything, because it mixed and matched geometry that was instantiated and also geometry that was created by the tool. So in this case, I'm basically making a focus for the geometry that is going to be only instantiated. For 1.0, I have taken out some of the features out, and this legacy release is still going to be available as its own download. But 1.0 release really is the kind of a new starting point for the tool, so that only instantiated geometry will be created and more focused tool on the workflow and actual usability of the tool. And I'm going to go through this zip file that you're going to have available, that you will have, and also I wanted to remind you that anyone who got the tool during the initial release of the angle-based instancing and after that is going to get this upgrade for free. So basically it's the same download link. So just a very quick walkthrough how the tool works. I'm going to go through this zip file. Through, but at the end of it, we are going to have basically our geometry collection that we have set up and then that we can instantiate. And the instantiation happens very simple. We give it a polyline, and just the tool also supports multiple polylines, and you can just go ahead and draw it out, and you go to instantiate geometry. So the geometry is angle based, and there's a bunch of options for it, but you can see that the curve has been snapped to the closest piece that we have an angle piece for. In this case, this is a 45-degree piece geometry that's going to be, since my options inside the geometry node, the main node of the tool, can be said to snap to the 45 degrees. You can see it has found the closest angle that we have a piece for, and it has snapped to this angle. So this takes out a lot of work for us to creating ideal polylines that's going to be ideally aligned. Then we can just go ahead and start moving this around. You can see in this case, I just wanted to showcase ability to align the curve along like uneven terrain. And yeah, so this is just a quick simple for the showcase. And the pipe tool is still available. It's going to be still fully supported, and basically the only difference between this setup and that, and basically the more common one with the something like railings, is just a couple of parameter changes that I have made inside here, which I explained during the video. But yeah, so this is just a quick walkthrough of the tool that you can use, and again I can just go ahead and start creating my polylines. I can instantiate geometry as much as I want. So yeah, so let's not waste any more time, let's get to the heap file and explain how to work with the tool. The best way for you to get started with geometry along curved nodes is by opening up the included heap file, and we're basically, it goes through the required, basically the typical workflow for you to set up your geometry for it to be successfully instantiated along the polyline. So at the end of it, we have a couple of examples of instantiating geometry, and the idea is that to basically there are different methods that you can set up your attributes for the main node, so you can get a little bit different results from it. So I just want to go ahead and go through this setup and explain. I have a couple of text boxes that explains a little bit more about it, but basically I just want to go through the setup and explain the nodes along the way. So let's get started. So the actual nodes that are required for you to instantiate your geometry are going to be three nodes: the collection piece, the collection IO, and Instantiate. So the first one is actually the collection piece. So since we have to set up our attributes for each piece that we want to instantiate, we need a node that's going to set up all of our attributes easily. And so this is what the collection piece does. And basically each piece that you want to instantiate for something like this, where I have these, if you go inside this network, you can see I'm using, for each one of these pieces, I'm actually using the collection piece node to set up all of my attributes individually for each piece. So this can be automated with the for each loops and the attributes on it, but in this case I just want to showcase the basic setup and these required attributes. So this is not this node is not necessary if you have all of your attributes that the tool expects, that you have set up your own in your own way, that this node doesn't really do anything except for the setting of the attributes. The next piece is the collection IO. So the collection IO is used to save out our geometry collections. So you can imagine that once we have set up our geometry with the collection piece node, we want to basically set it up as its own collection. So these are pieces that are part of the one collection, and this happens basically once we just merge all of these pieces together. We do some I'm going to go to this a little bit later, but basically we just go ahead and say I want to save it as its own collection. We give it a directory and we give it a collection name, and what it's going to do is going to save this save geometry, whatever the directory we have saved this as our save directory. So each piece can be in its own different path on the disk, because it's going to look for each piece's save directory path. And this directory is used for the JSON file that's going to also be saved out. And if you take a look at it, I have saved this collection out already. In this case, I have this JSON file, and basically however many pieces we had merged together, each one of them are actually its own entry in a JSON file. And basically we have saved out the attribute values as its own entries inside the JSON file. So this is going to be used later on to import our collection back into the Houdini, and the main node of the tool is geometry instantiation. So this node actually does the instantiation of geometry. There are options for us to choose the pieces and a bunch of other options that I'm going to go through. But the idea is that the first input is going to be our curve. If you see, if I start to move our curve, it's going to automatically start instantiating pieces across. Here, I'll actually go ahead and align it with my ground, like that. Then we can basically just go ahead and add new pieces, move them around. You can see right now it's actually not going to, since I have set up my snapping to be at 90 degrees, you can see that it's going to snap to 90 degrees angle snapping to instantiate the corner piece always. So this is one thing to note. So this doesn't look all that good because of the height difference, but you can imagine that you can start to put your pieces like that. So the default input is actually, I don't think it's going to be actually necessary. I'm going to probably remove the fourth input from the HDA. In your version, there's not going to be the fourth input for the node, but the third input is actually the Boolean. Basically, we can actually create a holes for our curve. If you take a look at something like a box, you can go ahead and you can create that's kind of like entries. We turn off the grid snapping. You see, we can create entries for our geometry, for our curve, like that. And now let's go through this setup. So first of all, I have to create my own geometry. So this is basically the big part of this network is actually creation of my own unique geometry that I want to instantiate across the curve, because I have to make my own geometry because I want to share it with everyone. So the idea behind here is actually has nothing to do with the actual tool, but basically the idea is that I am creating different curves with these angles. So basically with the space separated list, what angles I want. I'm in this for each loop and basically rotating the curve's last point by that amount. And I am merging them with these straight pieces, and I am writing out the angle attribute for each one of these polylines. And then I'm creating my collections. So I have collection A, just to demonstrate, and collection B. Let's go to the collection A. So now that we have our curves, we want to go ahead and go through each one of these curves. Let me go put it in a flat shaded. And I'm using this logic that works for all of these angles to actually create this geometry. So inside here, it's very simple. I'm basically extruding a bunch of extrudes. I'm not going to go through this because this is not really about this creation of geometry. So basically, but this is setup works with the different geometry. And at the end of it, I have geometry, and I have also transferred back the angle attribute for these pieces that came originally from the polylines. That's because I actually want to split the geometry and basically I'm going to use that to split my geometry and then setting it up with the collection piece attribute. And now that we have separated each geometry piece, we can go ahead and feed it into the geometry collection node. So inside here, there's going to be a couple of visualizers for you to help a bit on setting up a couple of attributes that are necessary for the main node to instantiate it. So first of all, there's going to be a translate node, so you can adjust your geometry. So this translate is going to be done before any of the operations, basically any of the attribute setups here. So it's just easy way for you to maybe move it a bit. But overall, I would it's basically there's no real difference between just putting down the translate before you use this collection piece node. So let's take a look at all these attributes. So one important attribute is we have to separate our geometry pieces as a straight piece, as a corner piece, or as a cap piece. So this geometry can be only used as a straight piece, as a straight part of the polyline. So that means I have marked it only as a straight. And if you go to the attributes, you can see it's going to be a string array that actually says what kind of geometry it is. In this case, I just use it as a straight piece. Then I have to give it a name. So the name is going to be used when you save out this geometry on disk. So this name is going to be used on disk as a file name, and that's basically it. So this is also going to be used in a couple of other attribute setting later down the line. So the pattern name is going to be a quick name for the for usage for the main instantiate geometry. So in this case, I'm using this is just an A. So because in one of the instantiation modes, we can actually say what kind of pattern you want to repeat along the straight parts of the polylines. So let's say I have two straight pieces, I have A and B, and let's say I want my pattern to be ABA. So this is how I would basically name. So for the easy way for me to write patterns, I have given them a quick name as a pattern name to identify them inside the pattern parameter. So in previous version I actually used the name as an identifier, but since the name can be a lot longer and it's not very useful for you to write it out, it's very long and it's not very useful. So quick identifier should be used instead. In this case I'm just using A and B. Then I have to give it an angle. So in this case we can I can even not write it basically as I can disable as an angle, because it's going to by default, since all of the attributes has to be present, even though a couple of attributes are actually only used for something like corner pieces, all attributes are going to be written. And let's say I have unchecked this angle piece, let's say angle, you can see it's going to be instantiated anyway, but it's going to be instantiated at the default at 0. So in this case I can even not write anything. Here I just go ahead and uncheck it, you can see, and by default it's going to be instantiated at 0, and that's fine. Angle is only used for the corners. So the save directory is going to be a directory where to save this geometry piece. So in this case I'm using the heap file example collection A directory. And there's also two options for you to toggle what kind of a string you want to save out on disk. So it's kind of a edge case scenarios for these two, but let's take a look at my save file. So in this case, you can see my save directory attribute is heap file, and this is I say, okay, I want to actually expand the save directory. If I expand it, you can see I'm actually now using default full path on disk for this geometry. So this, you might want to do it or might not. So in this case, it is good actually to save it as if you have like a special identifier for your environment variable. This is good to keep a collection between different heap files, to keep basically your collections in one place where you can access it with the same environment variable. With your custom environment variable, you can basically load it up using like that. So, but you can also expand it. So the expansion is also option. And there's also option to say that this is a relevant, so this is a relative reference. So the relative reference is used only if you are actually referencing in this save directory path, you're actually referencing the other string. In, let's say I have like a null node and I have like a string parameter that actually is, let's say I'm using the common save location for all of the geometry pieces, and as a easier way for me to set up all of these and update save location, I can create a string parameter. Let's say string parameter like that, and I actually go ahead and let's say I'm using the same save file inside here. You can see I have same file, and let's say I'm going to start relative reference inside here. So because of the how Houdini works, it's not going to recognize that this parameter has to be basically how it has to go. I have to go ahead and take a look at this parameter's value. You can see if I do not select the, you can see now the save directory is actually the channel expression. This one, it hasn't gone up to this parameter and sampled from this parameter. So this is why the is relative reference is option. If you select it is relative reference, you can see it's going to be it's going to look up the parameter of this one. Basically going to evaluate this expression, going to go to this parameter and evaluate that parameter. So this is just a thing that I came across to maybe save some headaches. The next important attribute is the size attribute. So since we have to, for each piece, we have to accommodate it. We basically have to accommodate for each piece its size. We have to know its size, and this is where we set it up with this parameter. And since all the geometry has to be aligned along the z-axis, the straight pieces should all be, majority of the piece should be on the positive z-axis. So depending how your pieces work, you can just go ahead and play around with the sizes of the geometry. But in most cases, you basically just want to make sure that your straight pieces are all in the positive z-axis. And then the size of it, you can use the bounding box z size of it. You can see if you go ahead and select it, you can see that this visualizer that I have set up to better see how it works, how it sees the size of the piece. You can use this one, or you can uncheck it and use these two vector 2 parameters, which basically going to take the difference between basically the distance between these two values, basically the difference between these two values. You see I can go to the negative ones and 0, and since the size cannot be 0, it's going to be just positive difference between these two values. And you can basically just, wherever your piece is located along the z-axis, you can more easily align it with these two parameters if you want to use it manually. Because there is option that maybe your piece is a little bit more on the, because there can be, depending on how your pieces are structured, it's totally fine that some of the pieces are maybe a little bit overlapping in the negative z-axis or like that. So just to visualize the better, line it up and see its size, you can use these two parameters or use the bounding z-axis like I have inside this case. So the offset is only for the corner pieces, so I'm not going to, in this, it's not relevant for the straight pieces. And these are all the attributes that you need for it to work inside Houdini only. If you want to use it inside Unreal, you need to set up couple more attributes. So there's basically these attributes. Some of these attributes are basically in mind created with the idea that you save the geometry out and you want to import it inside Unreal Engine. You need your bake folder, so basically where you want to import your geometry, which folder you want to save you want to import this geometry in. In this case, I'm using my, and I'm going to talk about Unreal part of it a little bit later. Basically the folder inside the content browser where you want to save your geometry when you import it. Also you can give it an Unreal material, and also you can construct Unreal instance attribute. So the Unreal instance is basically just a combination of the bake folder and the name of the geometry. And if you wanted to, if you are using this, in this case, if you would have used this geometry primarily only for the Unreal Engine, I will probably start naming scheme for this geometry with the SM as a static mesh underscore. But for this demonstration, I didn't bother it, but it is kind of a standard way for naming static meshes inside Unreal Engine with the prefix of SM. And you can see that these attributes are all created. And Unreal instance, you can see that if I go ahead and basically I can write my own Unreal instance attribute if I want, or I can construct it from attributes. And if I construct it, you can see it has taken the bake folder, and then it has went ahead and used the name of it to write the name of this piece. And I'm going to talk about a little bit later about Unreal part of it. But if you're not using it inside Unreal, you can use only these, and that's totally fine. It's just going to write out these attributes as empty. If you uncheck these, you're going to write the empty attributes, and that's totally fine. That's the whole setup for the straight pieces. Let's talk about the corners. So the corners are a little bit more involved, and there's a couple more options for you to precisely set your size of your pieces. So let's go ahead and to demonstrate how it works. Let me go ahead and go somehow like that on top view, and let me go ahead. So this, you can see this is a positive z-axis is now pointing towards here. Let me go ahead and take a screenshot. So the corner pieces should basically, wherever the corner happens, so wherever it should be basically it shouldn't be entirely on the positive z-axis. You can see actually in this case the entirety of most of the geometry is actually on the negative z-axis. As you can see, the 0 is here, and you can see that it's actually right in the middle of the where the 0 overlaps. Basically, whatever the thickness of the piece is, You see it's right in the middle for this piece, where the positive axis, only the half of the thickness of the piece is actually on the positive z-axis. And to explain it how a bit more, I have walked to close. So this is the positive z-axis, and you can imagine this corner is like a, so since this is the 90-degree corner, you can imagine that this is a polyline, and you can see that this piece should be basically want to cut out these two parts of the geometry. So basically this is the size. The size is the incoming size, basically what the forward, and then the outgoing is the offset. Offset, which is this attribute value. So basically these two values has to be set up. In this case, it's very simple to set up because this piece has the same size and the offset of it, like that. But if it's not, it can basically, it has to be different size. Input inside, basically the size and offset can be different. So let's say if our piece would have been bigger, so that means the offset has to be also bigger. So this is where this another parameter comes in handy. Or even you can use this parameter, this handle, to move around size. And basically you see that the size is being measured from the end of the first, basically from the end of the incoming size. So there's like a pivot inside here, and then basically since the angles can go in different directions, it basically is pivoted inside here for the offset part of it. You can just move it around since the angle can be different, and it's just going to take a difference between these two parts and write it as its size. So since I have tested it out on different geometry, it can be a little bit more confusing to see what kind of a geometry it is necessary. Basically, what's the offset of the geometry? It can be pretty confusing. But the best part of it, that these attributes are not set in stone. We can always go back and precisely align your geometry later on. But this is kind of a, if you start to work with it, you will see that it kind of makes sense how the handle is set up to set up the offset attribute for the corner pieces. And basically the same thing for the other ones. And since we need our plus and negative, basically we need our positive angles and also negative values, we can just mirror the piece and set up our geometry. You see in this case I have my pattern name is 90, so that's fine to write the pattern name 90 because the corners cannot be used inside the patterns because we do not control which corner. Basically, if the corner is 90 degrees, that means the 90 degrees piece is going to be instantiated. So we cannot control that one, but it still needs some pattern name, so it's okay to just give it its angle amount. And for the quick reference for the angle, it's pretty simple. When you are looking at the geometry along the basically positive z-axis, any geometry that goes into the left is going to be positive 90 degrees, and the negative is going to be on the right side. So this basically comes from the transform node. So if you put on transform node, you can see if you move your transform handle into the right, you can see it's negative angle, and positive it's and if you go to the left, it's going to be positive value. So this is where basically positive and negative values come from. You can see basically the angle is being calculated from the previous point forward direction to the basically left or the right side as an angle. So that's basically it for the angles. It's pretty straightforward. And for demonstration, I just made two different angles for this. And then basically just go ahead and merge it together and output it out. And that's it for the collection. So I also I'm doing basically the same thing for the collection B. And one unique part of it is that there's actually can be a piece that can actually be valid for multiple collections. So in this case, I have this universal corner. And this corner is so generic that it can be used for both of these collections. And basically, I'm using this I'm saving it inside different folder, and I'm saying that this is can be used as a corner or as a cap. I'm setting it all up inside here, and basically I can use it on both collections. And now it will be a good idea to save our collection. So saving of collection is done with the collection IO node. But before that we have to set up a couple things. I setting up by normal, but we also need a way to separate the geometry. So internally it's going to basically use it's going to pack each piece based on the primitive attribute, and right now we do not have this primitive attribute set up. So the easiest way for us to separate each one of these pieces is by promoting the name attribute that we set up for each one of these pieces into the primitive attribute and change its name to something like a piece, like that. So the piece attribute is actually internally this collection IO node is going to look for the piece attribute. So that's why we are actually creating this piece attribute that's going to be saved inside here, and it's going to separate each one of these geometry for the tool to know how to save the geometry individually. And if you do not want to manually put down all of the network that is necessary for it, what you can do is just put down a search for the collection IO node, collection IO, and before pressing this node you can hold down Control, and you can see the control node is going to set up basically the collection piece and the promotion attribute promote node that's necessary for collection IO node to work. So this is a quick way to get you started with the tool. Basically it's because it's important to have this piece attribute. So that's just a way to quickly set this up. So let's go ahead and go back to the collection IO. So we have our piece attribute. We want to go ahead and say point to the directory where we want to save our JSON file, JSON file that we can then load up, basically that's going to store all the attribute values that we can later on pull from to import our collection back. So I'm pointing out to this example collection, which is basically here. Let me go ahead and delete all of these pieces to showcase from start. So basically this directory, collection name, collection A, that's fine. Let me set up to this switch, so collection A, like that, that's fine. And you go ahead and say save collection. And it should basically set up everything here. So you can see, since I pointed to my universal pieces to be in different directory, you can see it's in different directory than my collection A pieces. And you can see all of these pieces has used the name attribute as their value, as their name on disk. And now that we have saved our geometry, you can see this geometry node is going to actually create the geometry as a packed primitives. Basically all of the geometry is going to be packed after this node. And we can use, if this is in the save mode, we not have to load our collection from disk. We can already use this output of this collection IO node as inside our instantiate geometry node. You can see, like in this case, I am already using the output of this node as the input for the main instantiate node. And now let's take a look at how can we import our collection from disk, basically all the files that we just saved from the IO node, how we can load these up from disk using the same node, and this is done inside here. So I'm going to delete this collection name. So right now I'm just using the directory. I'm in the load mode. I am pointing to the same directory where my JSON file is, and then there should basically drop down menu should show only the JSON files. And you know that I have one collection A, just go ahead and select it, and it should basically go through the JSON file and open up and see the saved directories of the files of geometry pieces, and it's going to go ahead and automatically load them up. If it doesn't, you can go ahead and try these top cook option like generate work cook output node like these, but these should basically automatically be loaded up like that. And then we can again use it directly without setting up any attributes like we did before. We can go ahead and straight up use our collection pieces. And now let's take a look at the main node of the toolkit is the Instantiate geometry node. So let's take a look at the basics, how we can control which piece is being copied. So first of all, on the straight pieces, when on the straight parts of the geometry that you instantiate, you can use in these controls, and there's a piece distribution. You can use either a cycle. A cycle is basically the repeated pattern of all of these geometry pieces. You can even use an offset. Basically, all the pieces are going to be used in the in the order. Then you can offset them and then also randomize the order of them. And then you can also filter the pieces. So let's say I want only the A piece. You see, only the A piece is going to be instantiated along the curve. If you want only B, then B. And then you can select multiple, like A and B. In this case, since I have only two straight pieces, it's going to be only two. But if you have more, you can select which piece you want to actually cycle between with the piece filter parameter. Then there's also a randomize. So the random is just as it sounds, it's just a random, and then you can also select the piece that you actually want to randomize. And then the pattern, and the pattern I was talking about, you see if there's no pattern, it's going to be empty. But let's say I want my pattern to be A, B, and A. You see it starts with A, B, and A, and it's going to repeat this pattern along the straight parts of the geometry. And one thing to note that it has to complete the pattern at least one time, at least for this implementation. So that means if you have a big pattern, you can see that some of the geometry is going to be squished if your pattern is very long. So it's probably a good idea for this one to have, if you have parts where there are very small slivers of these straight parts, probably pattern should be also accommodating that. At least for now, this is the implementation, but in the future, I'm sure there's a way to cut off at least the part of the pattern if it doesn't fit in the small part of the parts of the straight part of the polylines. And now let's talk a little bit about corners. So the reason why this geometry is being copied on the corners is because we selected a copy corners by angle. If I go ahead and deselect it, you can see the corners has been replaced with this universal corner, which has been set up inside here. You can see inside here, I have one corner that I set up previously in my collection, and it is marked as a universal corner. So that means that if there's no exact angle piece for that corner, that means instantiate this piece. So that's why I have selected this corner piece to be instantiated across corners. If I go ahead and deselect it, you can see there's not going to be any corners on the for the polyline. You can see in dropdown it's going to only show the corner pieces, and since it doesn't make sense for me to copy angle pieces for all these, universal corner is the logical piece to select. And then you can go ahead and also nudge it a bit if your alignments are not exact. So basically it's going to move all the pieces along. So, but if we have selected this corner by angle, that means the angles has been found. It's going to be instantiated. Those pieces are going to be instantiated. But let's say we have this way. We creating our polylines, but we do not have a exact angle piece that we can instantiate our geometry on that angle. So this is where the universal corner again comes in handy. So you see, if I go ahead and deselect, you can see we have still selected this copy corners by angle, and then this found angle is going to be instantiate correct geometry. But in this case, this angle is not either 45 or negative 40. It's basically not 90 or 45 degree angle. That means there's no piece that can be instantiated. So that's why we select universal corner. And actually to see what kind of corner it is, you can go ahead and go inside the network and select this piece you can see it's actually negative 75-degree angle. So if you want to make sure that your corner is always going to be snapped to the pieces that you actually have, you can go to the setup and you can set up your snap angle. The snap angle is going to basically go to the closest angle that divides with this snap angle value without the remainder. So if I want to say, okay, I want to only 45 or 90-degree angles, I say, okay, snap by 45 degrees. You can see it's going to go ahead and snap to the closest one, which is the 90 degrees. And you actually go ahead to the curves, and you can go ahead and move it, and you can see, and then as soon as it gets closer to the 45, it's going to snap to the 45 degrees, and also the other way around. So the snapping is actually very nice to have. This is basically the part of the power of this tool, the snapping option. And also it works best with the open lines, but it also works with the closed lines. Like in this case, I'm actually putting the closed polyline side here, but I am boolean it out like that. So this is for the corners, so that's very important. So the caps, you will have noticed that there's also this cap geometry. So we can also change the little bit of we can change the size and nudge a bit, because the corners are kind of unique because they are either starts or ends of the pattern, and it's a little weird. So we have this size, so you can see if you change the size of these pieces, the actual polyline that starts the straight piece actually going to be moved a bit, and also the nudge is going to move the actual piece on these. But the caps are great if you want to finish off your polylines with some sort of, always with geometry, something like a fence post or something like that. Yeah. And again, this universal piece is being used, you see, in this case I'm using this as a universal corner, A, because, and the only reason it appears inside here, because I have marked it inside here in my universal corner as also as a corner or a cap piece. So that's why this geometry is only shows inside here, like that. And there are a couple more options you can experiment when you are instantiating your geometry. So the evaluation of the angles in the, basically we can evaluate our angles between the on the x, y, basically z and x axis, which is basically the plane of the grid plane, or in the 3D space. So for something like these fences, I would always select the z and x plane, because basically this is going to look at the angles that we can see from the top view of these. So that means it's not going to take in account any y height of these, because let's say our first point is like here, and another one here, and these basically they are not on the same level field. The angles are going to change dramatically based on the height of each of the y height of each point. So for something like these, where you want to precise corners, I would always select the angles evaluation in the z and x plane. And for the original, and if you remember that this tool basically started with the pipes, but for the pipes I always would select the 3D space, because since these pipes can be rotated however we want to be aligned at any angle, we need to get our angles precise between, basically we want to get our angles between in the any position, since these pipes can be aligned along in any way. So in this case I would select the 3D space to evaluate these angles. And also the up direction is very important on how geometry is being instantiated. So for the instantiation, if you know a little bit about Houdini, it has a normal attribute, which in this case always it becomes the same. The normal is going to be the direction of the polyline, the previous direction of the polyline. So let's say this is 0 and 1. The normal is going to point on the opposite direction of the previous point of the corner or the polyline, like that. But the up direction can be basically either the y direction, the 90-degree direction by the polyline, or the next point. And basically this is where these three options come in handy. And there's really no need to know how exactly it works. Just go ahead and play around with it to see what kind of geometry works, what kind of a up direction works best for something like these pipes. If we want our normal for our up to point to the next point, because these pipes has to point to the next point like that. So, but for the instantiate, I have put it on the y-axis. And there's one more option to align the instantiate geometry along the x and z plane. So I talk about a little bit inside one of these text bubbles. But basically, if we evaluate our angles in z and x, you probably also want to turn on this align instance attributes along x and z plane. So this is going to be most relevant for some time for the geometry that you are actually moving along the y direction, like you're moving it around in elevation in the y-axis, in the something like this. In this case, where you are moving it around, you want to play with these parameters to make sure that geometry attributes are aligned correctly. So I think you can go ahead and go through this. You read up these text bubbles to entirety of the Houdini part, and this is going to end the Houdini part. Let's talk a little bit about how to get this geometry inside Unreal Engine and use the tool inside there. So first of all, I did some updates when I walked through this whole tool. You will maybe notice that right now it's more streamlined with only 3 inputs, so the 4th one is going to be removed. And I also started to think about the naming scheme of the geometry that we actually want to import into the Unreal Engine. And I thought about I should probably set up attribute, because there is a unique attribute also that controls the bake name inside the content browser inside the Unreal Engine. What the mesh will be named. We can actually set it up as the Unreal attribute, and then when we bake out geometry in the Unreal, it's going to be named like that. So what I went ahead and added another entry for the collection piece node, which is called Unreal output name. So this attribute controls the name of the static mesh when we bake out our geometry. And what I basically have, we can add it as a basically like our own name. Let's say we write our own name, but most likely you want to use your already set up name for the piece that is inside here. So what I have here is basically a simple toggle to say the name and prefix it with the static mesh. And if you go to the geometry spreadsheet, Unreal output name, you can see right now it's going to SM static mesh and then the name of the geometry. And this is also going to update all the attributes that are dependent on the name of the geometry inside the content browser, like the Unreal instance attribute. Like now you can see it's now sampling from the output name attribute, and the bake folder is going to basically the same. So right now we are also Unreal instance is being updated, attributes being updated and sampled from the output name. So that's basically the idea, to actually keep it in line with the naming scheme and a little bit more straightforward when we actually want to start importing geometry. So right now I basically just went ahead and set up basically just turned on this toggle. I have my attributes set up and go ahead and say selection. You're going to show that this file already exists. I can go ahead and overwrite the collection. That's going to save out the geometry and JSON file from again. And let's go ahead to the Unreal Engine and let's try to import this geometry. So I have set up this simple file, basically just an empty file, and with the Unreal Engine imported. So right now I want to go ahead and import this geometry. So the easiest way, the default way you can do it is using the let's search for the import Houdini asset, and by default there's going to be a Houdini BGO import. which is basically just a wrapper around the file node of the Houdini file node wrapper inside Unreal Engine. So let's go ahead and restart session. Let's get Houdini engine ready. So in this asset, I just want to go ahead and point to one of my saved files on disk. So let's go ahead and select these three dots, and let's go to the folder where I save my collection. And let's say I want to get my corner 45. Let's import it. You can see it, and since we set up our attributes, I also set up my Unreal material attribute. It's going to also apply the simple material that I have already, basically the path that I have showed in the content browser. It's going to also pick up this material and apply to it. So that's cool. And what I want to do is go ahead and now I want to bake out this geometry. And let's go ahead and bake it out. So this is going to detach this geometry from the HDA file, and basically it's going to save it in the content browser. So let's go ahead and go and find it. And if you remember, I point all of my geometry from this collection into the bake folder, basically game, which is equivalent for the content. Content, copy to points tool, collection A. Copy to points tools, collections, collection A. You can see this attribute, setting up this attribute has made sure that when we bake out the geometry, it's going to be placed in this folder. So that's pretty much it. We can go ahead and import all of our geometry like this. So this is going to be pretty slow with doing it one by one. So that's why I'm going to actually use my import geometry tool, which I have showcased in many videos previously, and I'm actually going to also include it, which basically uses a PDG network to import a bunch of geometry at the same time, so that we do not have to do it manually one by one. So in this case, in these parameters, I have used this tool in different videos, so I'm maybe going to link to where I explain it a little bit more. So, but the only thing that I want to do is, since I want to import a bunch of geometry, for the cook type, I'm going to go to the PDG, and for the directory, I'm going to paste my main directory of collections. So since I have two directories inside here, I want to sample from both of them. So I'm going to won't select the subdirectory. I'm just going to press recursive like that. And since this tool was created for something with a little bit different purpose in mind, it's going to pick up the file name as a base name. It's not going to sample any attribute values that it found on the geometry that we have saved out. So that's a negative for now. So what we can do is basically, but since the prefixing geometry with SM is so common, I actually added this feature when I worked with other geometry. So basically we are going to still sample from file name, but just like we did with our geometry inside the Houdini, where we prefixed name attribute with a static mesh, we're going to prefix it also inside here. And all you have to do is go ahead and say cook output. It's going to start cooking, and it's actually going to start appearing. The geometry should start appearing. So geometry is very simple. You can see it's going to start import. You can see already the material is being picked up. And now all I want to do is go ahead and detach it from HDA. Go ahead and say bake. And you can see all of these pieces has been picked up from collection A inside content browser with the SM prefix, and also our universal piece is also picked up. So that's exactly what I wanted. So we have gotten our geometry. Let me go ahead and delete this HDA. So our geometry is here. Now we want to basically want to go ahead and instantiate our geometry along the curve HDA. So the easiest way for you to do is just go ahead and drag in the HDA inside the content browser. But for me, since I'm using it on my own setup, I have added my HDA into the basically my own package file and then basically there's a side effects package, and there's a my package. Basically that means that these HDAs that are primarily used for inside Unreal Engine can be actually accessed from these Houdini tools tabs. But this does require a little bit of a setup, and since this video is not really about that, you can just go ahead and drag the same HDA inside here, and it's going to be the same workflow anyways inside the content browser and save it there. But in this case, I'm just going to drag it from my Houdini tools. Now that we have instantiated, there's a couple of options that we want to start looking at. So let me go ahead and delete these. So first of all, I want to go ahead and drag out this curve, and automatically it's going to add a simple curve, and this is going to be our equivalent of the polylines inside Unreal, inside Houdini. So let's go ahead and drag it. Let's make something like this to test out over 90 degrees and 40 degrees, and then maybe like our non-uniform, basically our universal corner, something like that. So, and since you want to instantiate this geometry that is already on the inside content browser, we have to think about how to get this information from. So this is where the data table is going to come in handy. So since I'm going to give you this simple heap file, what you are going to also get is this this structure, which is basically data table structure, which mirrors all the attributes that I have saved inside our inside the JSON file. And we can basically import our JSON file and specify that this JSON file uses this structure to pick up all of these attributes and import them as a data table. You see there's name, pattern, and all the attribute values has been created with the correct types. And let's go ahead and try to import our collection inside here. So what I have here is, you can basically go ahead and drag in the JSON file inside content browser. So I'm going to go to collections, and inside here I'm going to go ahead and drag in the JSON file, and all you have to do is go ahead and select the JSON file, basically the type, the data table row type, and it's going to be geometry collection, and basically just say apply. And if there's no errors, that's pretty much everything that you want to hear, because you can see it's going to automatically pick up all of this geometry. Everything has been imported correctly, and you can see it's even Unreal instance is now pointing to our static mesh, because we have correctly set up all of our bakes, and everything has been correctly set up. References has been baked out correctly, because these meshes has been correctly referenced from our collection on disk inside here. Now we want to actually start referencing the geometry that we actually have created, and this is where the collection data table is going to come in handy. So the first input is our polyline, and the second one is going to be our instance geometry. So just take this data table that we just imported and drag it inside, and that's it. And the whole Boolean shape, we can also do it a little bit later. And now we just have to set up our parameters so that we are starting to sample the values from the data table instead of the Houdini setup, which is actual geometry. So inside the controls, go to the collection fetch. It's going to be our data table. Instead of instance geometry, instance points. And by default, it should already generate something if it has found the collection. Basically, if everything here is correctly imported and found inside here, by default it's going to set as a piece distribution as random. It's going to already distribute these pieces. And let's recreate the setup for the a little bit closer to the Houdini setup. So first of all, we want to maybe say that we want to copy corners by angle. And let's go ahead inside the setup. Let's put our snap angle to something like a 15 degrees. So this should already make sure that we are actually instantiating the corners, 90 degree corners. It's here, and so this is not going to, let's try to get our 45 degree corner. actually going to be outwards like that. And also now we got our 45 degrees, and let's go ahead and drag it here to check out our if our universal corner is working. So something like this, there's no corner. Let's go ahead and say, let's use our universal corner. So it's going to be a drop down menu. We can go ahead and select universal corner. You can see we are instantiating this universal corner. So the nudge also going to work just fine. Okay, caps. Let's go ahead and cap the geometry. Let's select our universal corner. So we have our caps. That's good. What else? Also, right, so there's a uniqueness. If you want to only work inside Unreal Engine, there is a problem with the parameter when you are in the piece distribution called the pattern. So the pattern node is a little bit weird inside Unreal, because basically inside the Houdini HDA, I am using a script to basically automatically append to the pattern the previous whatever the already string is being selected. Basically, it's a trick that appends pattern name to already existing pattern, but inside the Unreal Engine it doesn't work. So you see, right now we can only select one piece, only one piece as a pattern, and it's basically very glitchy. So what you can do is override this pattern. If you're working inside the inside Unreal, you could basically say evaluate Unreal pattern, and then just press it, and then this is going to be disabled, and now we're using this a string parameter where we have to manually write our pattern. And in this case, I know that I have A and B pieces. I say A and B A. You can see this is going to basically override this pattern, and we just have to manually write it, manually write the pattern. But it's going to work just fine with the manual pattern writing. So this should work just fine. This kind of workaround maybe in the future is going to be updated and going to work also inside, work with the scripts, with the menu scripts that works inside Houdini. So that's basically it for the working inside the Unreal Engine, how to get your pieces working inside Unreal Engine. And obviously all of this works with any geometry, with your own geometry, or even from the asset packs. As long as they are correctly aligned, it should work just fine. So, and I have not yet tested it, but I actually want to showcase one cool trick that you can actually do when you actually open up Houdini session sync. So actually I had opened up my session sync. So this is the session sync, and the difference right now, let's take a look at Houdini Instantiate geometry. You can see the actual output of this node is just the points. So there's no really geometry. That basically any geometry is basically just references to the files on the file paths inside the content browser of the Unreal Engine. So one thing that you actually can get around with, actually override the second input inside here with the collection. So put down a IO node, collection IO node, and what you can do is go ahead and point to the directory of the collection. Let me just copy, and then the collection name, it should be like here. Let's load it up, and you can see it's going to showcase the error that this is not a valid collection because we inside our collection JSON file we use the heap save directory, use a heap environment variable to now the tool is looking for the heap environment variable, and whenever you are inside the opened Houdini session sync, it's basically in a temporary folder of the windows. There's no this is in the incorrect location, this heap file. But we can do actually go ahead and say save, and I'm going to save it inside my basically inside the directory where I created my collections from. So I created from the main heap file. Let me go ahead and say this is the Unreal file. Override this one. Override. You can see now that heap file has been updated. It has been automatically loaded up my collection. And what you can do is actually go ahead and select it and use this as instantiation. And if you go ahead and say again, I now want to sample from the input 2 and instantiate geometry, and you go to the Unreal Engine, you can see it's still going to work, but any of these static meshes, you can see that now the static meshes are actually new geometry that has been created by Unreal Engine and basically by Houdini engine. So this is the temporary geometry that has been created. So we are no longer referencing the geometry that we baked out inside content browser, but this is a basically copy geometry for the instantiation. So this is one thing to note, but this is good for testing out geometry pieces, and if you do not want to bake out it again, basically immediately, so there is maybe kind of a valid point of using it like this way, and maybe in the future I could probably update it so that you can it would be a little bit more automatic to sample collection from disk instead of from the content browser. But for now, it's just going to be like that, because in most cases, because in 99% of the cases, you just want to sample, you basically want to instantiate your geometry that you have already set up inside your content browser. So yeah, I just wanted to showcase this cool trick that you can use to get your collections from the session synced Houdini instance. And I almost forgot to showcase the Boolean option for the tool. So what we can do is go ahead and input some geometry that we're going to use as the Boolean. So you can basically just go ahead and get some default cube from the place actors tab, just drag it inside, and after that you can go to the Vault Boolean shapes and basically start selection and use this box. Now we are using this as a Boolean. We can just go ahead and scale it a bit and just move it inside here. You can see it has created the entry, but the negative part is that this cube is completely opaque. So what you can do is just create your simple material that has some opacity on it. In this case I have like a opacity of the 0.5. You can just apply to these objects to see a little bit better how your geometry would look like, or even you can make it completely opaque, which is then going to be hard to see, but you will be able to see basically the end result of the Boolean shapes like that. So it's probably more elegant way of doing these Boolean shapes, but for the initial release, I think that's good enough for now. So yeah, just want to very quickly showcase the Boolean ability. But that's pretty much it for the version 1.0 of the tool. I really appreciate if you would give me some feedback for it, and I'm sure there's going to be new updates coming in the future. So go ahead, try it out, and tell me what you think about it, and see you next time.